Hello everyone, welcome to this video where we'll explore three fundamental object-oriented programming exercise in Java. Today we will cover a Point2D class demonstrating encapsulation and method overloading, a shape interface showing polymorphism, and the last one is a vehicle inheritance hierarchy. Let's dive into this key object-oriented programming concept with practical examples. First exercise is Point2D. Let's look at the Point2D class, which represents a point in two-dimension coordinate system. The class has two private instance variables x and y to store the coordinates. They are declared private for encapsulation, meaning they can only be accessed through the class methods and constructor. This constructor initializes a new Point2D object with specified x and y coordinates. This keyword is used to refer to the instance variable when there is a naming confliction with parameters. And we are here to distance methods. The class implements three different methods to calculate distance. The first method uses the Euclidean distance formula. In this, the formula is here, and the square is meaning of square root, and po is meaning power of here to here. Yeah? It's mean of this power of 2 plus this power of 2. And we are here to getting method in here because we are used to x and y values in another distance methods overloading. The second method is method overloading, same method but different parameters. It reuses the first method to avoid code duplication. And the third method is a static belonging to class rather than any specified instance. It can be called without creating a Point2D object. And the last one is midpoint method. This method calculates the midpoint between this point and another point, returning a new Point2D object representing that midpoint. We are here to test program. I am creating a main method in here for executing the program, and I am creating a new object in Point2D. First object is point1. Point1's x equals to 3, y equals to 4, point2's x equals to 6, and y equals to 8. And I am printing here the point1's information in here. This is getting from here, and this is getting from here, like this. And in this first method, this system out println is writing here to console. I'm so sorry, I'm changing here the distance from P1 to 0 to 0, calculating the how many away distance from here to here. And the second method is using like this because we are not into two variables, we are into distance a point object. And third method is a static, so we are using the Point2D dot distance. This is the using for like this, and we are using the polymorphism in here. I'm creating a new Point2D object named by mid. It's equal to P1 to midpoint P2 using this method, and outputting in here to mid. Let's start and looking to how is running this program. Firstly, we are looking to here, it's true, and it's also true, and calculating to here from distance P1 to 0.0, and calculating to here, and calculating the here. If we change these values and starting again the program, this value is changing. The first exercise is finished. Let's going to second exercise. The second exercise is interface definition. An interface is a construct that class must adhere to. It defines abstract methods. Classes that implement this interface must provide concrete implementation for these methods. Class implements the shape interface. It has its own attributes, its mean radius, and provides concrete implementation for calculating area and perimeter. Firstly, we are creating an object in here, circle object, and we are getting the radius from circle object because we are using the radius value to calculating area and perimeter like this. The calculating area is overriding by shape interface. Its mean of editing for circle, optimized for circle, it's returning to pi times radius. Its mean of pi times radius power of 2, and we are overriding perimeter. We are overriding perimeter in here, and it's similar for calculate area method. It's calculate to 2 times pi times radius, and we are going to rectangles class. This class also implement the shape interface, but with different implementation for the area and perimeter calculations based on the width and height attributes. We are creating a new rectangle object in here, and we are getting methods are here because we are again using the width and height in calculation, and we are similar to circle, overriding again calculating area and calculate the perimeter. And let's going to test program in here. We are going to again creating a main object for executable project. And I am creating a new circle object in here with 5 radius, and I am creating a new rectangle object with 4 width and 6 height. And I am printing to console circles information in here. The circle get radius getting from here, and calculations is from here, and writing the console. And then similar to rectangle like circle, and using polymorphism in here, I am creating a new polymorphism object is shape 1 and shape 2. And shape 1 is coming from circle, shape 2 is coming from rectangle, and I am writing here to polymorphism object information. Let's start the code and looking the output. Yes, that's true. Circles is radius equals to 5 coming from here, and calculations area and perimeter circle for radius equals to 5, and similar to rectangle, all this same, and using polymorphism is here, and the shape area is coming from here, the shape area is coming from here. And the second exercise is finished too. Let's going to third exercise. This is a super class, base class. It's same thing. It has common attributes, make and year, shared by all vehicles, and a method to display two vehicles informations. We are creating a vehicle object in here, and we are getting to make and years from here, because we are again to using the make and years in display information. It's output, and then we are creating a car class. The car class extends from vehicles, means car inherits from vehicle. That super make and years calls the superclass constructor. The car class has an additional attribute specified to car, to numbers, and overrides the display information, editing for car, optimizing for car. This code is copying here to paste in here and adding for numbers because we need the car is numbers. It's similar to motorcycles to extends vehicles. Motorcycles different attributes specified to motorcycles to engine type. We are creating a motorcycle object in here. This superclass is coming from here. And then we are getting the engine type because we are again used to engine type in here for displaying info. And we are overriding the method from vehicles. Lastly, we are testing program in here. Again, we are create a main object in here for executable program. And I am creating a tree object in here. Vehicles has two information, make and year. Cars and motorcycles has three information, make, year, numbers for car, make, years, engine type for motorcycles. And I am writing to console vehicle informations in here and displaying to vehicle informations that's coming from here. What it do this code? This code is make and manufacturing years to writing to console. And then I am using to \n because splitting this car information from vehicle information. And then I am displaying info for car and similar to motorcycles. And I am using the polymorphism in here. I am creating two new variables. Variables 1 creating a new car, variables 2 is creating new motorcycles, and I am displaying infos in here. Let's look at the output. That's looking true. Firstly, we are writing the vehicle informations, that's true, and that's coming from here, that's here, and likely similar for car information and motorcycle information. And I'm using vehicles reference with polymorphism. This is coming from here, and this is coming from here. And thank you for watching this tutorial on Java object-oriented programming concept. We have converted to implementation of Point2D Class and shape informations and vehicle inheritance hierarchy to demonstrate encapsulation, method overloading and interfaces, inheritance and polymorphism, and method overriding. I hope this video helps you understanding this core object-oriented programming. Thank you for watching this video.